All right, guys, here's your review for the second exam, test 2, which we're getting ready to take in a few weeks. There are 11 problems. Problem number 1, we're solving for x, and you want to make sure you simplify to the final lowest terms. So first we want to distribute this -10, and when we do that distribution, we'll get 90x minus 20, and then we carry down the minus 8x equals 8x plus 3 on the right side. We combine like terms, 90x minus that 80x. And then we're also going to carry over this positive 8x. So you notice the 8x's are going to cancel when I add 8x over here on the left side. So that just leaves me with 90x. And then I'll add 20 to both sides of this equation, and that'll give me 23 on the right side. We divide both sides by 90. We see our final answer is 23/90. Question 2, Dion drove to the mountains last weekend. There was heavy traffic on the way there, and the time that it took him on the way there was 8 hours. When he came home, there was no traffic, so he got there in 6 hours. If Dion's average rate, so the speed he was traveling, is 26 miles per hour faster on the way home, how far does Dion live? And we want to know that distance from the mountains. And don't round. So here we're going to let X represent the distance from Dion's home to the mountains. And remember, to get distance, we're comparing rate times the time. So we notice that on the way there, Dion's time that he had when he on the way there, it took him 6 hours. So that would be that time over 6. That'll give us his rate. We just took that D equals RT formula and solved it for distance. The time that it took for him to get, so we had the wrong number here. The time that it took for him to get home was 6 hours. So we have X over 6 minus the time that it took for him to drive to the mountains. That was X over 8. So in total, that rate is 26 miles per hour. All right, so I wanted to add some more notes here for you. What you notice is the distance formula is rate times time, but because we are given the rate here of 26 miles, we just rewrote both the distance coming home and the distance to the mountains in that same form, distance over time. Again, we don't know the distance of the time, the distance to the mountain, so we use X to represent that amount. And then we wrote an expression for the distance coming home, which will be X over 6, and then the distance going to the mountains, which took a little bit longer in traffic, X over 8. But we were told that the rate was 26 miles faster on the trip home, so we took away that distance that it took to get there. When we subtract these two numbers, we can't make that difference or calculate that subtraction until we get common denominators. So we wrote our common denominator of 6 and 8 as 24. Over here on the right side, that 26 is a whole number, so we want to make it a fraction by putting it over 1. We change each of these denominators so that we have 24 in the denominator. To make this 6 of 24, we have to multiply times 4. So that first fraction we multiplied in our numerator, 4 times x, we get 4x. And the second fraction, to make that 8 of 24, we have to multiply times 3. So in the numerator, we have 3x. And on the right side of the equal sign, to make that 1 of 24, we have to multiply by 24. So in our numerator, we had to multiply 26 times 24. That gave us 624. Remember, at this point, you can get rid of your denominators and just look at the numerators only. So we have 4x minus 3x equals 624. And 4x minus 3x, that's just x. So we see that that distance will be 624 as our answer. For the next problem, we have 4 times x minus 6 plus 5 greater than or equal to negative 5 plus 5x. And remember, for these inequalities, that little caveat, if you multiply or divide by a negative number, you must reverse that inequality symbol. We want to do that here. So for this problem, when we distribute, we get 4 times the x minus 6, and 4 times x gives us 4x. 4 times minus 6 gives us negative 24. Carry down your plus 5, the greater than or equal to symbol, minus 5 plus 5x. And then we combine like terms. Negative 24 plus 5 gives us negative 19. And then we're going to add the 19 to both sides of this inequality and subtract the 5x from both sides. And 4x minus 5x gives us negative x. The 19's cancel on the left. Negative 5 plus 19 gives us 14. Now you want to see this minus x as being negative 1. That reminds you to divide both sides by negative 1 to get rid of that minus sign in front of the x. But because we are dividing by a negative number, we must reverse that symbol. So it changes from greater than or equal to less than or equal to. And we'll get x equals negative, or x less than or equal to negative 14. For the next problem, we are solving this compound inequality with the word or. So remember, you have 2 types of compound inequalities, those with the word or and those with the word and. So the inequalities with the word or, when you graph these inequalities, you should always get 2 values. Sometimes the circles are closed in, sometimes they're open, but you should always be shading outwardly. If you have an inequality with the word and, you'll get those 2 values. Again, sometimes those circles are going to be shaded in, sometimes they're not, but you should shade in the middle, in between these 2 numbers that you receive. So in our case, we have or, so we see our graph, we're shading outwardly, but we just solve both of these inequalities. On the left side, we subtract 6 and then divide by 2, or excuse me, divide by 3. So we'll get our minus 3 or minus 6 that we divided by positive 3, and that gave us x less than negative 2. So subtract 6 from both sides, we'll get negative 6, and then we divide that by 3 to get x less than negative 2. On the right side, we subtract 3 from both sides. So 7 minus 3 would give us 4, and then we divide that 4 by 4, and we'll get x greater than 1. So here are our 2 values we want to plot on our number line. We have x less than negative 2. So at negative 2, you see we have an open circle. Remember, you're going to use open circles for less than or equal to. Less than, greater than, you're going to use open circles. For less than or equal to or greater than or equal to, you're going to use closed circles. So for the first inequality, we have less than, which means we should use open circle. And then we're shading to the left, shading in the direction of negative infinity. For the second inequality, we have x greater than 1. So greater than 1, this should also be an open circle here, guys. And we're going to shade to the right. That's in the direction of positive infinity. So open circle at 1. Open circle at negative 2, shade to the left of negative 2, shade to the right of positive 1. For the next problem, we're factoring here. Well, we see these 2 factors and we're finding the product. So we're multiplying using distribution. 4w times minus 3w squared gives us negative 12w cubed. 4w times 9w gives us 36w squared. And then 4w times the minus 3 gives us negative 12w. Negative 6 times negative 3w squared, that gives us a positive 18w squared. And then negative 6 times the 9w gives us negative 54w. Negative 6 times negative 3 gives us a positive 18. From here, we want to combine like terms. So there's just one w cubed term. So we wrote it as negative 12w cubed. And then 36w squared plus 18w squared, that gives us 54w squared. And then negative 12w minus 54w gives us minus 66. And then plus that 18, here's our answer. For the next problem, we have 5w minus, or 5y minus 4 squared. Now I rewrote this expression. This is how you want to expand this expression, 5w or 5y minus 4 times itself. So 5y minus 4 times itself, we distribute. 5y times 5y gives us 25y squared. And then 5y times that minus 4, we get negative 20y. In the middle, you have negative 4 times 5y gives us negative 20y. And negative 4 times negative 4 are positive 16. These two inner terms we combine to get negative 40y. So our answer, 25y squared minus 40y plus 16. The next problem, we want to factor as much as possible. We're looking for the greatest common factor between 16 u squared x to the 6th power and 8y to the 6th power u to the 6th power x to the 2nd power. So just looking at the numerical portion, 16 and 8, we see our greatest common factor would be 8. That's the largest number we can factor from, 8 and 16. And then our u values, I have u squared, u to the 6th. So the greatest number of u values I can factor is u squared. My x, I have x to the 6th and x squared. So again, it will be x squared. Collectively, our GCF, greatest common factor, is going to be 8u squared x squared. And when we factor from both of these terms, remember that's the same as me dividing both of these terms by 8u squared x squared. And what we get when we factor 8u squared x squared from our first term, we get 2x to the 4th power left over. When we factor from our second term, we get y to the 6th power. This is our answer. We don't have to have this 1 here. You can just write it as y to the 6th power. For the next problem, we see that our leading coefficient is not equal to 1. So you want to start by multiplying the first and the last term together. 6 times 12 gives us 72. And we want to find two numbers where when we multiply them, the product, we get 72. But when we add them, we get our middle number, which is 18. So you want to start there to create your 4-term expression that we're then going to factor using the grouping method. So the two numbers whose product is 72 and sum is 18 is 6 and 12. So we replace that middle term, 18x, we replace it with those two factors, which are 12x and 6x. And then we carry down the 12. From there, because we've now expanded this to get a 4-term polynomial, we're going to factor by grouping. So group together the first 2 terms, also group together the last 2 terms, and then you're going to factor the GCF from each of those groups. So our GCF between 6x squared and 12x is going to be 6x. In parentheses, when we factor 6x, we'll get x plus 2. Plus, and now our GCF between 6x and 12 would be 6, and we'll be left with x plus 2 in parentheses. Now we know we factored correctly because x plus 2 is the same for both terms. Our solution comes from the 2 terms that are in front. That's one of our factors. So 6x plus 6. And then our second part of the solution is going to be that shared factor, x plus 2. Now notice that we can still factor from 6x and 6, we can factor out a 6. And that gives us x plus 1. And here we'll have x plus 2. So our final answer should be 6 times the x plus 1 times x plus 2. Now, if you factored another way, you should still wind up with the same answer. Notice over here we have 3x plus 3 and 2x plus 4. From both of these, you can still factor. From that first term, I could factor 3. So I'll get x plus 1 in parentheses. And from that second term, I can factor out 2. Right? So that 2 that we factored, let me erase that plus sign. So that 2 that we factored will leave us with x plus 1 in parentheses. So that 3 times 2 gives us 6 outside, and both of them have that attached factor of x plus 1. And then over here we had actually x plus 2. So you see we wound up with the same answer, x plus 1 times x plus 2, with a 6 outside of the parentheses. So you should get the same answer. For the next problem, we have 4 terms originally, so we're going to group together the first 2 terms, group together the last 2 terms, and then find the GCF. So our GCF for the first 2 terms is y. When we factor y from xy, we get x. When we factor y from the 5y, we get 5. So y outside parentheses, x plus 5 inside the parentheses. From the second term, we factor a GCF of minus 3. And when we factor minus 3 from that 3x right here, we get 3x. When we factor, or x left over, when we factor the minus 3 from the minus 15, we get positive 5. And our solution will come from, one part of the solution will be that shared factor x plus 5. The other part will come from these terms that are in front of the parentheses. So y minus 3. So here's our solution, x plus 5 times y minus 3. For the next problem, we have a difference of perfect squares, x squared minus 9. What are we squaring in order to get x squared? It's x. So our a term is equal to x. Our b term, we're asking ourselves, what are we squaring in order to get 9? And that's going to be 3. So everywhere we see a, we're going to substitute x. Everywhere we see b, we're going to substitute 3. So we factor it using a plus b and a minus b method. So we have x plus 3, x minus 3 as our solution. Next, we want to simplify and add the cube root of 128 times x to the 8th power times y to the 4th power, plus the 3x squared y times the cube root of 16x squared y. So the 16 and the 128, we find the largest perfect cube number that can divide into 128 and 16. So we factored that 128 using 64 times 2. We factored the 16 using 8 times 2. So we can simplify these numbers further. 64, when we take that cube root of 64, we get 4. And when we take this cube root of 8, we get 2, but 2 times the 3 that's already out there will give us 6. Okay, so we got to multiply there to get 6. The x squared term and the y term on that second factor, or that second polynomial here, we just leave that underneath. We don't do any other simplifying. But the x to the 8th power and the y to the 4th power, we can factor that x to the 8th power using x cubed. So when we multiply, remember we're looking for sets of 3. So how many multiples of 3 are there in 8? It's going to be that 6, so the 6th power. And we'll have 2 left over. So it's x to the 6th power and the 2 left over. Y to the fourth power is just one set of 3, so we'll have the y cubed times the 1 left over. So we can factor x to the 6, and we can also factor y cubed. So we simplify x to the 6. That gives us x squared. We simplify the y to the third power. That's going to give us just one y right here outside the parentheses. All right, so we're left underneath that radical expression for that first term. When we get done simplifying, we're left with 2x squared y. And for the second term, we already had that 2x squared y. We carried out the cube root of 8 to get 2 times 3. So now we can add these two terms together. 4 plus 6 gives us 10 x squared y outside of the radical expression, and then we keep the cubed root of 2x squared y underneath. So you want to simplify down to your lowest terms. For the next problem, you got to rationalize this denominator, the square root of 13 minus 3, and the square root of 13 plus the square root of 3. So remember, we got to multiply by the square root of 13 minus the square root of 3, both of the top and the bottom, and then we distribute. So square root 13 times square root 13 gives us 13 without that radical. And then the square root 3 times that square root 13, we have a positive and we have a minus square root 3 times square root 13. That's going to wind up being the square root of 39 minus square root 39. So both of those are going to cancel out. Square root 39 minus square root 39. Those two are going to cancel. And we'll be left with just that square root 3 times itself. That gave us a minus 3 without the radical. So in our denominator, 13 minus 3, we get 10. In the numerator, when we distribute, we get square root 13 times square root 13. That's just going to be 13. And then 2 of those square root 3 times 13. So that's minus 2 times square root 39 plus 3. A negative times a negative will give us positive 3 without that radical. So we add 13 plus 3 to get 16 minus the 2 square root 39. And we simplify that a little bit further. We can divide each of these terms by 2. So we'll get 8 minus that square root 39 over 5. And you can separate it into 2 fractions, or you could leave it combined as 8 minus square root 39 over 5. That's fine. For the next problem, we're dividing. This time we got to clear out that I, that imaginary number I, from the denominator. So we must multiply the denominator and the numerator by negative 9 minus 4i. And when we distribute negative 9 times negative 9, we get negative 9 squared, that's 81. Negative 9 times that minus 4i, that gives us negative 36i. And then positive 4i times negative 9, that'll give us another negative 36i. So we have a positive and a negative 36i. And those are going to cancel. So we're left with 4i minus 4i. That'll give us negative 4i squared. But remember, every time you see I squared, that's equal to negative 1. All right, so keep in mind this I squared, this has become negative 1. So that's 81, and then that minus 16 times minus 1 becomes positive 16. So we wind up adding in the denominator, 81 plus 16 to get 97. In the numerator, we have negative 10 times negative 9 gives us positive 90. Negative 10 times this minus 4i gives us positive 40i. And I times negative 9 gives us negative 9i. Lastly, the I times negative 4i gives us negative 4i squared. But remember, I squared equals negative 1. And 4 times negative 1, this will become a positive 4. So we're going to add that 4 to 90 in order to get 94 plus the 31i. All right, and so we can leave this as 94 plus 31i over 97. Next, you have a quadratic equation for a and b. The first one, we have to first isolate this square term. This is our square root property we want to apply. So we subtract 1 from both sides and we get x plus 9 squared equals -1. Now, once you see that you have some term squared, your square root property tells you that that value underneath that radical could be positive or negative. So we write it as either positive square root -1 or negative square root. Now, remember that the square root of -1 equals I. So anytime we see that square root of -1, it equals I. So we rewrite it as x plus 9 equals plus or minus I. And to solve, we would subtract 9 from both sides. And that's how we get x equals -9 plus or minus that I. And we can separate it, write it two separate terms, -9 plus I, or -9 minus the letter I. For the next problem, we use quadratic formula, making our A value equal 5, our B term is equal to 7, and our C is equal to 1. So we'll get -7 plus or minus 7 squared minus 4 times 5 times 1 divided by 2 times 5. That's our 2 times our A term. So 10 in the denominator when we simplify. 7 squared, we get 49, and then minus that 4 times 5 times 1 is 20. 49 minus 20 gives us 29. So here's our two solutions. X equals -7 plus square root 29 over 10, or -7 minus square root 29 over 10. Now for the last question, we want to look at the area of a rectangle is 23 square feet. And remember, the area formula for a rectangle is length times width. And then we're told that the length is 4 feet shorter. So that's 4 minus that width, 4 minus W right here. We want to find the area, and then we want to find the length and width. So we're going to use that information to find the length and width. Using our formula, length times width, and the expression where we're told that that length is 4 feet shorter than 4 times the width. So we multiply 4 times the width, and then we subtract 4 from it. This expression, this 4W minus 4, we're going to substitute that for our length into the formula. So we have W equals, or the area equals W, that's the short side, times the long side. But remember, we substituted 4W minus 4 as the long side. Now we need to distribute here. W times W, or 4W, gives us 4W squared. W times the minus 4 gives us minus 4W, and it equals our area. We were given the area of 63. So we carry down 63. We subtract that 63 from both sides, and that gives us 4W squared minus 4W minus the 63, which we then use quadratic formula. We substitute 4 for A value, -4 for the B value, and -63 for the C term. So using that quadratic formula, we have 4 plus or minus 16 minus 4 times 4. That's our A times B, 4AB, and -63 is our C term. When we simplify underneath that radical, 16 minus that 4 times 4, remember we have to multiply first. So 16 times that 63, we get 1,024. And this is a perfect square. The square root of 1,064 gives us 32. We carry down the 4, and in the denominator, 2 times A gives us 8. Our two solutions, 4 plus 32 over 8 or 4 minus 32 over 8. And you can do that addition and subtraction separately, but you'll wind up with the one positive and one negative. You want to use the positive value only. So our positive value for W is 3.5 or 3.5. That gives us just the width. And to get the length, we have to now substitute. So that 3.5 times 4 minus 4 gives us our length, which is 18. So this is our answer, the length and width of the rectangle, 18 and 3.5. So that's our review for test 2.